Okay, so we just finished watching our Coke and Mentos video. It was cool, right? Okay. Did you know that if you this makes me laugh. Did you know that if you drop Mentos into a fresh bottle of Coke, the soda will immediately start to fizz and shoot out of the top of the bottle in a fountain? I literally just showed you a video of it doing that. Okay. And I know it says Coke, but we all know that Diet Coke works better, right? Okay. A physics class hypothesized that dropping more Mentos into the bottle would create a higher stream of soda. The class conducted an experiment with several packages of the candy and 8 2-liter bottles of soda. Here are the results. The group who used 5 Mentos and 7 Mentos accidentally knocked over their Coke bottles. The sad part is that I have a group of kids in mind that were probably group 5 and group 7. Is that bad? I'm sorry. Please forgive me. So now no data is available for these entries. Okay? So first of all, we're going to make a scatter plot of the data. Oh, they're calculators. So you have all have your calculators, right? And they're all charged? Because I know you use them so much over break. Oh, the cookie. You had to use a calculator for the cookie recipes, of course. It's all right. Do you remember how to make a scatter plot in your calculator, or is it okay if I remind you? Remind? Okay. So I'm going to start a new document, and I want to start in a list in a spreadsheet. Okay? So list and spreadsheet, which is number 4. You guys all have this worksheet in front of you, so I'm going to go ahead and zoom in on my calculator so you can see my screen really well, okay? You can see the data right in front of you, yes? Okay. So what's going to go in the X column? 1, 2, 3, 4. Uh-oh. We don't have anything for 5, so can we put 5 in? Nope. 6. Uh-oh. Oh, then 8. Okay. And what should we call this column? X is boring. It doesn't mean anything to us. How about if we call it Mentos? Isn't that what it says? The number of Mentos? M-E-N-T-O-S. If you accidentally put in Mentors, that's fine. Nobody's going to look at your spelling but you. Okay. Oh, no. No. Let's go ahead and put something at the top of the Y column while we're here. What should we put? Height. Guys, please don't ask me how to spell height. It's literally on your page. You guys are so funny. 6, 11, 14, 16, 20, and 22. Okay, now we're going to look at that in just a second, but I'd like to look at the table real quick. Okay, looking at the table real quick with you guys. Okay. Can we make any predictions for these two? I mean, is predictions really a math skill? Yeah. It's a huge math skill, right? Okay. So, but do we have enough information to make predictions for these two? We can make good guesses, couldn't we? What do we think this might be? Maybe 18? Why are you saying 18? Oh, so you think it should be somewhere between 16 and 20, right? So why did you automatically say 18? Because it's right in the middle, right? Okay. And that would be a perfect guess if this was a linear function, right? We know it's not going to be, we know it's not a linear function. We already had that conversation at the beginning, right? So you know well enough to know that it should be between 16 and 20, and that's a good start, right? Do you think it should be closer to 16 or closer to 20? Okay. I'm not telling you if you're right or wrong right now. I'm just letting you know, okay? What about this? What do you think this might be? 21, because you think it should be between those two, right? Okay. So I'm just going to let it go at that for now. I just wanted to have a quick discussion about predictions. Okay. For the record, predictions is a higher level thinking skill. So you just did some higher level thinking. You might be tired, but just keep at it, okay, guys? Okay. So, make a scatter plot of the data. So let's go back to the scatter plot real quick. Okay? Wake up. Okay, there we go. We're going to add a page. Do you remember how to add a page? Now, why am I adding a page here instead of starting a new document? So first of all, I'm going to be able to go back, right? But when I add a page on these calculators, they're related to each other, right? They can use the same information from one page to the next. So if I add a page, especially now a data and statistics page, it's going to use the stuff that I just put on my spreadsheet. Now, if I was a betting woman, and I'm not, I would bet that yours looks different than mine. And that's okay. So don't worry about that if ours look different right now. In a second, they'll look the same, but right now, it's okay if they look different, okay? I need to move my cursor down here, right there. Click to add variable. What variable should go along the x-axis of my graph? Mentos. So I'm going to choose Mentos, and to me, this is the cool part. Haha, it just moved. And then let's go add our variable on the y-axis, right? What's that? What characteristics of the graph, this graph right here, indicate that a square root function might create a good model for the data? So it has a curve. And for the record, I'm going to argue with you for just a second, so please don't take it personal, okay? Because we're trying to think about characteristics that make it specifically square root. So the first thing I want to say is, so does a quadratic. But a curve for sure means it's not linear, right? Okay, so what other characteristics might it have that would make it a good indication that it's a square root function? So it's not straight. So is it okay if we just leave curve, or do you want to go ahead and write not straight? Because I agree with you, right? It's not a straight line, so we know it's not going to be linear because it's curved, right? Okay. What other indications might this have that it would be square root? Can you think about a square root in your head? What does it look like? Whoosh. Right? So it's steeper at the beginning? Any other characteristics that you can think of? What's true about all these points? What'd you say? They connect? They could, right? They could connect. So that means we know it's probably not, well, we don't know if it's continuous or discrete right now, right? Right now it's actually discrete because I didn't test 1.5 bottles or 2.5 bottles, did I? I only tested 1 bottle and 2 bottles and 3 bottles. Okay? What about they are increasing? Would that help us know something? Because there are functions that are decreasing from the beginning, right? So it's not going to be exponential decay, is it? Because exponential decay is decreasing from the beginning, isn't it? So that helps us decide. What about this one? It looks like one. How many times in previous math classes has your teacher told you, guys, we can't go by looks? Well, I know, but it looks like a right angle. Nope, we can't go by looks. Isn't that very true? So why am I saying it's okay that we can say this right now? We are making predictions. That's exactly right. And we're looking at characteristics, right? I'm not saying this is exactly a square root function right now. Because I'll tell you right now, it's not. But it does make a square root function shape, doesn't it? It looks like one. Let h be the function that approximates the height of the spray, h in feet, that results from dropping x mentos into the Coke bottle. You okay with that? Can you translate that for me? Let h of x be the function, and we're saying the height of the spray is h, that results from dropping x mentos into a Coke bottle. We don't know anything else yet here, but I want to make sure you understand that we're saying this is the function. So it's going to be the function equals something else. Are you okay with that? Okay. So the rule for h of x, now we're going to talk specifics. The rule for h of x can be written in the form, aha, we got that part right. H of x equals a times the square root of x, where a is a constant. Thinking about our transformation rules, what does a do to a function? It stretches it or compresses it, right? Makes it, in this case, if we're talking about a square root, we're talking about like steeper or shallower, right? If we're talking about a line, steeper or shallower. If we're talking about a parabola, steeper or shallow, not like that, but like this, right? Or shallower, like that. You okay with that? Okay. So we need to determine a value for this a. So let's go back to our calculator and look for just a second. If I do menu and analyze my function, how do you think I could get the equation of the function? Oh, regression. That would be super easy, right? Are we wanting a quadratic? Uh-oh. There's not a square root, is there? Well, we're going to have to do this instead. Plot function. So what are we going to have to do instead? Plot function. What are we going to do when we plot the function? How are we going to figure out a? Yeah, we're going to guess. Okay. Do you think it should be 1? I can't even see it because it's too low, right? Okay, so what do you know about, what about a? It's definitely going to be greater than 1, isn't it? Okay, so I'm going to give you a couple minutes, 2 or 3 minutes right now, to try to find out what a is. I want you to figure out what a is. Once you think you have a, put your calculator down so I know that you're finished. Okay, you can get as specific as you want, but I'm going to give you a couple minutes right now to try to find it yourself. And when you think you have it, don't tell anyone. Not yet, anyway. Another couple minutes, or sorry, another couple seconds, because I see almost everybody's calculator down. All right, is that everybody? Somebody be brave and tell me what they got for A. 8, 6. Uh-huh. All right, let me see both your calculators real quick. Let's put it up on the screen. Let me see your calculators. Get up, walk back here with your calculator. I need a 6 and I need an 8. Okay. Okay, this is what I got right here. Okay. Now, it looks like this person tried multiple different times, right? Is that okay? Yeah, that's what I was asking you to do, isn't it? Okay. Maybe this person like double-clicked and deleted all your other ones. Okay. So, here's the deal. When we're asked in the worksheet, what are we only allowed to change? Only the A, right? So I'm going to delete this real quick because that actually changes a little more than we want to talk about right now. And if we leave it at 6, do you see? It's a little too low, right? So are you okay with us using 8 or something like that? Did anybody get anything else besides 6 or 8? I got 7.97. How is this one different than 8? Menu, analyze, plot function, 8. Square root of x. It's very similar, isn't it? Okay? It's just a matter of how, to me, I wasn't even paying attention to these down here. I was looking at where it's touching those 2 dots. Okay? So who's to say who is more correct, 7.97 or 8? That's just like me personal, right? So is it all right with everyone if as a whole group for the notes we use an 8? You okay with that? Okay. If you use something else and you want to keep using it, that is totally fine with me. Okay? So, while we're here, does this pass through 0, 0? If we had 0 Mentos, would it go 0 feet high? Yes, right? Why did nobody get assigned that point? Why did nobody get assigned 0 Mentos? That would be dumb, right? That would be boring. That for that group, they're just sitting there literally, right? Nobody wants to do that. But it would make sense that it should go through 0, 0, right? Now does it make sense that I didn't let you move it up or down or left or right? Because it should go through 0, 0, right? Okay. So what did we use? What value did we decide? So h of x should equal 8 square roots of x. And then tell how you found it. We guessed. Is that even allowed in math? But I'm always telling you to show your work, right? Didn't Maddie show her work? She had all those different equations on there, right? Trying to figure it out. Isn't that showing your work? Even when we're guessing? Is that allowed? Yeah. What's a more, I guess, mathematical way to say we guess? Trial and error. Okay? But we guess doesn't even really all cover it all the way, right? We didn't just pull some random number out of our head, did we? Didn't we use something to help us out? With our calculator. Yeah? With your value for A, use your function to estimate the height of the spray, x equals 5 and x equals 7. Why do we care about 5 and 7? We don't have any data for that, right? We used some prediction skills just a minute ago to try to figure it out, but we don't know for sure. So what we used was h of x equals 8 square root of x, right? What we're trying to find with x equals 5 is h of 5, aren't we? So 8 times the square root of 5. Somebody do that in the calculator, please. And let's also somebody else do h equals 7 at the same time. Sorry, x equals 7. So h of 7. And let's go to the hundredth. .166, so 17. 21.17 what? Oh, feet. Okay, is it important to label our answers when we're talking about word problems? Yeah. And what about 8 times the square root of 5? Feet, right? Guys, isn't that what we predicted a minute ago? We are so smart. So smart. With your function rule, estimate how high the soda would shoot out of the bottle if you used 10 Mentos. Why do we care about 10? We don't have that number. Nobody even did 10 Mentos, right? So is that something we can predict? Is it going to be more or less than 25? Is it going to be more or less than 30? And how do you know that? We guessed, but we educated guessed. That's not a word. I know, it's okay, sorry. Because we know it's a square root function, right? It's not going to go 16, 18, 20, 22, 24, 26, 28, right? What is it? 25.30 feet. Okay? Any questions about that so far? Guys, why did I have you do the predictions right here? I know we talked about it already. I need you to know the reason. On the last couple tests, we've been doing word problems. One of the word problems recently was how high above the bridge will the cable hang? You remember that one? And some people were getting things like 3 miles. Guys, is that a reasonable solution? If you don't know if your answers are reasonable, how can you be sure that you're okay with them? I need you to make sure that you are checking as you go that your answers are reasonable. Is 25 a reasonable answer for 10? Based on the data before, absolutely, right? Is 17.89 a reasonable answer for this? And 21? Yeah, right. We talked about that. We thought about that earlier. So checking reasonableness of an answer is important, and it comes into play in 5. You're going to do 4 and 5 for your homework. Okay? We'll talk about those at the beginning of class tomorrow. Do you have any questions about this so far? Okay.